All right, so this is kind of a, would say going to have some advanced topics in it, and things that I do that you will eventually be able to do. So this is going to be more of a watch. And then since I haven't given you all the files that you need, probably even more so. So let's go in and I will create a new assembly. All right, so we haven't done much in the way of assembly files, but it's going to come up and ask for an assembly. So if I was building that piece, my 1, 2, 3 blocks into the assembly and into looking at stack-ups, then I could go ahead and grab that file. As it is, I have some things going on in the background that we're going to start talking about, the fixtures, machine bases, the kind of tolerances that we can expect from CNC, from manual equipment. And so in my design library, I have created, and hopefully it comes back up, I have created some fixture items. And so I have a library of Kurt Weiss's. The 675 has been around forever, and probably within the last year they modified it to have that smaller form, and some people like it. Not everybody does. So I have a VF3 table and a VF4 table, so these are pretty good size CNC machines. All right, so if I just drag that in, there's nothing really to relate it to. It's just going to fix in 3D space. So what I'm concerned with here is that I have kind of the T-slot spacing so that I can view these locations. And as long as I haven't run a tool into this table, this is going to be flat, and it is going to be the buildup of all the rest of my manufacturing. So the flatness on the part, in our machining simulation here, is that it starts with the base. So the machine is capable of holding that flatness. And I'm not going to worry about positioning that. Let's see where the origin is, though. So if I pull that out, we'll go into the origin. And so I have a little separation, not quite ideal. That will bother me if I leave the little blue dots on for the origin. So we'll take that out. And then, so this table's nothing really fancy. Some things that I can do is open up a sketch, and I know that the envelope is on a VF3 is 40, and by 20, and I'll set those. Okay, and then that gives me kind of the working envelope if I need to visualize, am I going to be able to put this part on the table? And I'm going to go with the center line, and to help locate this, we'll go with another center line, and then between those two center lines, I'll have a midpoint relation that, I guess it would help to select a midpoint. So right-click and selecting the midpoint, and then going to the other one and selecting a midpoint that centers it on the table. All right, so that gives me an envelope to work with, and if I put a vise in place or go through that that process, well, let's go ahead and I will grab the Kurt vise, and I'm going to line that up. And so things in production, if I have room for 3 vices, then absolutely, I would have 3 vices, and then it would be the programmer's responsibility to establish work coordinates, methods for managing the height variations. So if I bought 5 of these vices, the beds would probably be within 2 or 3 thousandths of each other, so very close. The one time, and I bring this up because it really woke me up and basically scared me pretty good, was I put a 3600V, which is a CNC vise, next to my 675, and there's a 5/16 difference. So when the tool retracts at a ½ inch and goes flying over the top of the part by 3/16 of an inch, it's pretty impressive. So one of the things you'll want to check is, am I going to have those clearances? Well, we're doing just the one vise. So in the process of mating, I've selected the bottom of the vise, and I can go to a coincidence. And as I move this around, then I can see where it's going to line up. So most of these are going to have about a 4 or 5 inch tray that directs the coolant off of the ways and gets it out more towards the edges where it can collect and go back into the coolant tank. So for location, I'm going to pick a face and then the inside of the T-slot. If I make those coincident, then I've basically established, nope, not everything. I've established at least that I'm not going to rotate, but I haven't necessarily made that that tertiary. So I have a largest, flattest surface going down onto the table, the largest, flattest surface of my base, and then picking pretty much in the face. Mainly I just want this aligned. I know that there's going to be some variation when I actually put this on the table. And we're going to bring a, well, let's go ahead and position it. What do we have? So just kind of rough positioning it so it doesn't move unexpectedly. I can pick 2 faces, and there is my parallelism. All right, so that would be, oh, I needed a distance. All right, so let's take, I'll do Control Z. So the distance in effect in this case is going to kind of infer that there is parallelism. I can't have a linear distance and also have an angle, so it's one or the other. So about 9 inches should be pretty good, and we'll go ahead and accept. All right, so at this point it doesn't move. It's just as if I had taken my my T-slots and the bolts and clamped the vise to the table. I'm not going to show those. We could, but I'm not going to go through quite to that level. And like I said, if I wanted to have 3 more vices on the table, I could put a total of 4 vices so that we could jump from part to part to part. All right, so variations in the machine, the vibrations, the harmonics, the loading and unloading the table, that's where some of those surface variations are coming from. All right, so the next one, and we'll kind of build out, I'm going to go ahead and set this as a configuration. And so this is configuration 1, and I'm going to suppress my 2 components so that they don't exist and go back into the default. All right, so by using the configurations, oh, the sketch did, we'll go ahead and suppress that one as well. So as I switch between, now my default will be this table with the vise, and we can go up to another one as we compare between the 2 configurations. All right, so I had a VF4, and I'm going to drag that one in, and this one's a little bit different because we were looking at it from the standpoint of the envelope to contain a rotary table. Right, so as we go up in complexity for our setups and our build on the manufacturing side, I have to think in terms of what I'm going to be able to hold on to, clamping, and so this one has a subplate that is, what do we have, an inch and 3/8 subplate. So on different machines, I have a 2-inch, well, it started off life as 2-inch 20 years ago, okay, 16 years ago, and after taking subsequent 5,000s, 10,000s passes, it's maybe close to 1-inch 900, 1-inch 800, somewhere in there. All right, so we have sacrificial plates that we're going to be looking at as the tooling plate. So this plate gets bolted to the table, and then when I take a fly cutter or an end mill and create a decking routine that is going to establish flatness between the clamping surface and the top, I'm building up to that next level, but I'm also at the risk of injecting air. All right, so if that has any variation in it, it's going to affect the vise. All right, and then we go to The envelope is also where is the spindle able to travel on this machine. So at its very top at the peak, its tool change position, and also when we run it all the way down to the table, the spindle nose is not capable of touching the table. So depending on the gauge length of the tool holder and the length of the tool, I can still get to the table pretty easily, but the spindle won't make it. All right, we'll over travel, or we'll just get to its stop. So I really don't need to see the sketch other than to be able to turn it on or off and have that visual of what it's going to do for us. All right, so I didn't build these out quite that far, so let's go ahead and stay with the 675. So there's going to be some mechanism on this table that we're going to be able to clamp and have repeatability. So when we start thinking about the face, instead of lining the U shape into the T slot, now I would like to have a pattern of holes to be able to clamp, and also to position this where it's going to be easy for the operator to get to, right? Because that ergonomic portion of it is going to play in. So right about there, it's going to line up with that middle T slot, and oh yeah, it would help if it's not floating. So my anti-gravity device needs to sit on the table, and we'll give it a couple of quick relations for distance just to position it. And these are all relative. This is just helping me to visualize, to picture where this geometry is coming in and how I can utilize it. All right, and the table on AVF4 is 50 inches, so let's see how long this is, 4803. So we don't need to go that far out. And I will set a mate and a distance of 3 inches. All right, so up to this point, oops, wrong way. All right, we'll do a top view. And so at this point, the assumption is that we've brought our indicator down, we've located this within 1/1000th. So that 1/1000th of an inch over 6 inches doesn't relate to a whole lot of angle unless we're getting a lot larger. And in the manufacturing side is if I clamp a piece of stock and I want to run all the way around that stock, as long as I'm not locating on a finished surface and I can stay within the boundaries of that stock to generate the part, I don't necessarily have to have this within 1/1000th over the 6 inches. I will still be able to make good parts. The problem is going to be is when I take that good part and I flip it over and it is no longer aligned to my x-axis. When I lose that alignment, then I'm starting to inject the errors. All right, and I can reasonably well get the vise within half a thou without too much effort. You know, a little tap here, a little tap there, run the indicator across it, tighten it, and even in the process of tightening it, as the washer and the nut contact and start to move, in the process of tightening it, you're moving and you're changing the condition of the vise. All right, so that's where the stack up starts. And so we're trying to minimize that by having the flatness of the vise, the flatness of the table, those as our base conditions build up to where we can hold those tolerances that actually exist in the part. All right, so the next set of components that I'm going to deal with, I'll make a couple of virtual components here, is we got to get into parallels. Right, I'm not going to be able to set into the vise, or I'm going to have to make soft jaws for the parts to set on, in which case, are they steel soft jaws or are they aluminum soft jaws? And you know, it comes back to one of the first questions in the CAM class is always, how many? If we're making one, I don't really care. I'll figure out a way to hold on to it. If we're making 100, I want to do some fixturing that's going to be repeatable, very easy to use, get into the shapes of the part. And then when we start making 1,000, that's where I'm going to want the 5 vices on the table, or the rotary, or the horizontal. We make machine selections based on quantities and levels of production, and also the tolerances that we're handling over those levels of production. All right, so my virtual component then will be going into the assembly, and I'm going to create a new part, and just hitting the checkbox, we go back into the feature tree, and now I have a part 3, and these are going to be my parallels. All right, so I need some method to hold on to those. Actually, I need to be in the parallels, so I'm going to edit that part. And this is now an in context part. We'll get into this a little later on, but in the SolidWorks class. But this is going to be a quick way to visualize the effect of the parallels and some of the angularity. All right, so let's go to a 3. I'll open up a sketch on that face. Let's see, sketch. All right, so in effect, I'm tying my geometry to this geometry. And so this comes with tricks and traps that I'm going to have an external reference. And this is a very quick way of doing things, and it relates to top-down assemblies. So just to throw out some of the terminology and where I'm going with this. All right, so we'll draw a rectangle. I'm tying it to the jaw face and to the bed of the vise. And I want to make sure I don't miss the face and get the chamfer. I may have done that on the other one already. All right, so those look pretty good. And then for the heights, we'll set to equal, and then I can set to equal. And now I'm at a point where I can place a dimension. And parallels, unless they are thin parallels, are usually 1/8 of an inch. Right, and then the height, let's go with 1.5. All right, so now I'm ready to extrude those out. And I'm going to give it a vertex. And let's see, where's, well, it's going to be harder to rotate. That's interesting. Let's go to that one. All right, so now I have some parallels in place. All right, I'm not going to draw the holes through the center just to make them look like real parallels. All right, so let's see, the vise, did I miss one? All right, so that's still able to move. The distance, got the distance, so something's able to move. So let's, since that didn't fix itself when I dropped it in, I'm going to fix it in this configuration because I do not want the minus signs telling me that that can move. All right, so we set that, and because it moved, parallels moved into the part. Downside is that it updated, and we should be able to rebuild if it was tied correctly. Lost the location. So what's the first thing I should have done when I created the virtual component that I didn't do was save the file. So right now I have a question mark and a question mark. It lost its reference. Right, so that's something oversight on my part. All right, so a couple of things that I can do to correct that is make sure to save. This is the, we'll just call it a CNC stack up. And it's warning me that the name, and it's saved internally. All right, and I have those relations are there, but we've lost some of them. And the sketch is now floating, not too bad. So I'm going to do a display delete, and anything that has the question mark with it, highlight, delete, and then hopefully and list external references out of context. All right, so I painted myself into a corner pretty quickly with the virtual component. All right, so we'll go ahead and save, and then I'm going to edit the feature. Oh, no. Yeah, I did want to edit the feature. And the vertex that we had is no longer with that vertex, right? It's more of a naming convention than anything. So I'll repick the same face, except now it's going to be tied to the correct name. Yeah, still wants to create conflicting results. All right. So let's set this to a blind-in condition of 6. We'll see if I can break some of these relations. So a good example of why the top-down can be a little problematic. All right, so what did I build in here? I didn't have any more. Really, the horizontal? All right. I would not have expected that one to be showing up since they were related to each other. All right, my video card is also freaking out a little bit. All right, so I'm going to try and re-relate these. Still doesn't want to do that. All right, so there's still one relation to back out of, and that's the face. Oh, the sketch plane. Okay. So, all right, let me have it. All right, and then when I get upset at it, I just go ahead and tell it, don't show this to me again. All right, so we're going to get out of the sketch, let it do its thing. And the background, the one that isn't always apparent, is the edit the sketch plane. It had that external face. I need to remove and reapply. Selection still creating conflicting. Wow. All right, should have just drawn them over again. It got me to say it. All right, so backing out of these relations is not always easy. Let's see if we can. No, it's still going to be on the sketch face. Okay, I may have to edit that whole segment out so that I don't put everybody totally to sleep. All right. So once you figure out how to run the software, then I will set the same conditions. Let's go, I'll just go collinear and equal this time. Let's see, that edge and that edge are collinear. And that edge are collinear. And we'll set a 0.125 relation. And then we said they're going to be 1.5 tall. All right, so no errors. We have the external reference. Going to extrude those out. Instead of the vertex, I'm just going to go to the surface. I'll go to the backside. All right, so all of that to create a couple parallels. All right, and then what I want to get to is if a chip gets under the parallel, now where are we actually going to start building in some of these tolerances? So I want to open up another face, open up a sketch on another face. So new part. Let's go ahead and clean that out. And then this one's actually going to be the part. Well, I'll leave it at part 4. All right, and no check mark. All right, so when I put the stock in, and let's generate this as a parallelogram. and need to be able to see that edge. All right, so a little bit off of vertical and then drag it out. Yeah, probably should have done the center rectangle, so let's just make that one perpendicular. All right, so between the two surfaces of the parallel and the edge, well, it's going to let me have one of those. If I were to just put in 5/1000ths, all right, so simulating a burr or chip underneath the part, and we go 1 inch, and that connected that way. We're going to need to go off of the side, and we'll give it some distance, and I'll give it a length, making sure I get a linear 4.5. All right, so once everything goes into being defined, now I can actually get to where I can see that angle. All right, this is going to let me have, well, it keeps going to that one, but okay. Okay, so point is, the long way around to getting a number is over 4.5 inches. A 5/1000ths chip or a 5/1000ths burr is fairly negligible. As I take the fly cut across this 0.06 degrees, I have to convert that degrees, minutes, and seconds, but it's not going to be a whole lot. All right, so let's go ahead and raise that up to 10/1000ths and rebuild it. Oh, probably didn't need to do it. Let's just go ahead and accept it. And now my angle, I hate when that happens, is we're at 1/10 of a degree. All right, so on a very short part, we're not going to be accumulating a lot of errors, but all of a sudden, you know, if we really come down to it, I take a fly cut or I take an end mill pass across this face, that 10/1000ths, we're out of spec on our plus or minus dimension, and we haven't even started to talk about flatness and parallelism. So at that point, I may be able to get flatness on the part, bringing it over level, but then I'm out of spec on the parallelism. All right, so let's go ahead and build that out. And I want to try one more thing since I'm experimenting a little bit here. We'll try one more thing to see how it looks. And so this is going to go up to surface. Whatever the opening of the vise is going to be fine. So I'll just take it up to surface. All right, so my part with the angle in being representative of the error. And let's see, what do I need for a plane? All right, so I'm going to have to set a mid-plane. All right, so first reference, let's go to the part. Let's see if it'll give me the second reference. And all right, so mid-plane, that gives me something that I can sketch to. And so let's just, I want to create a hypothetical situation where the head is tilted over 5/1000ths, right? That's kind of extreme. Usually, well, that would indicate that the machine was crashed. 2 to 3/1000ths is probably a little easier to get to. So let's see what this looks like if I were to go a 3-point. Oh, needed that plane. And we'll pick up the 3-point. And I don't know if that's going to tie. Well, we'll see what it comes out as. So let's just say we were, what are we at? If I were doing a 3-inch fly cutter, that would be 1.5 on the radius. And it doesn't have to be that tall to create the geometry, so maybe 0.5. Oh, we're going to do the dance. All right, it wants to move. So we'll position it off of the edge. Yeah, 1/2 inch should do it. In the face, 0.5. Oops, maybe not that 0.5, 0.005. Below, and then that face on the geometry. All right, so my 3-inch fly cutter as a revolve is going to look like that. And then if I make that a tool and we gradually get it to be more and more, I'm going to start to see this generate a cup.